Oh, okay, so we've read a blob object. We're on to the next one now. Create a blob object. In the previous stage, we learned, I think that's supposed to be an ED, how to read a blob. In this stage, you'll add a blob to your Git repository by implementing the git hash object command. Okay, so let's close some of these windows down and open them up. Your program will be called like so. Okay, they're gonna call our shell script hash object -w and then a file. It is expected to store the data from file as a blob in Git objects and print a 40-character SHA to standard out. To verify your implementation, the tester will try to read the blob your program wrote. It'll do this using git cat file, the command you implemented in the previous stage. Okay. So we should be able to write it out and then immediately read it back out again. Okay, so let's see what we can do. So it's going to be hash object -w. So I kind of want to try this with just on my own to begin with, using just normal git. So if I create a file, so let's just touch test, we'll cat into test, maybe like hello world. So I want to do a git hash object, and then we hand it, okay, so write it, and then hand it test. And now we can do take that and do a git cat file. And we can get that back. Okay, so that's what we want to do. I mean, that doesn't seem too bad. So I'm going to hand it, okay, so for hash object, so we're going to have a new file here. So we have cat file. Let's just go ahead and touch hash object. Okay, and we'll go into hash object, and we're going to have a pub function hash object. Okay, so this is going to be called from our main file. If we take a look at main, this is what this looks like, right? So we're going to have hash object. We're going to want basically all the args past this. So we have args 1 as what this is, then 2 beyond. We're going to pass in. Okay, so hash object. Let's give it args 2 and beyond. Year upset, we want our args, which is going to be an array slice of, I guess, stirs. Wonder if that will work. I don't think they're that. Oh, use this as the mod. Okay. Hash object function. It wants these. Oh, they're actually okay. So it really is a string slice of strings. Okay. Okay. we are just going to go ahead and do the full thing here, right? So we want to check to see that it's a -w. That's not it. That's not the right one. We want if args of 0, so it's a new string slice, so starting with 0 here, if that equals -w. Okay, so if the args of 0, okay, so if that's -w, we should probably just match this. Let's match args of 0 as stir. So we have -w, and then I'll probably have like the actual thing down here. So this is going to be, now we have hash object, and then this one is going to be, we're going to hash the object. And then everything else, I think we're just going to ignore, or just say like unknown. We'll probably just have to do a print line, maybe an ePrint line. Unknown command, unknown option. Okay, that'll be fine. So in we want to hash the object. Okay, so we get that, and then we're going to get the file name. So that the file name equals args of 1. Okay, so we have this file name. I probably don't need to take ownership of this, so that's gonna be fine. Okay, so we have our file name. I want to now hash this. I guess it's not really hashing it, is it? I know it is hashing it. It's hashing it in a recoverable form. No, I want to hash it. I want to compress it. I want to compress it and get the hash of it. That's what I want. Okay, so I hash it and compress it. That's what it is. Okay, so we want to load up the file. So let's get the file equals what is it? File. I forgot the macro to load the file. It's like, oh, include stir. That's what it is. Now, okay, so include a UTF-8 encoded file as a string. This obviously could cause problems. Because like, what if it's not a string? I wonder if they would throw that at us. Because I believe in RealGit, it doesn't have to be a string. It can handle it with any type of file. That being said, we could probably just do include stir, hand it the file name. Oh, no, we can't do this because it must be a string literal. Okay, never mind. Oh, because that happens at compile time. That happens at compile time. I don't want this to happen at compile time. I want this to happen at runtime. So, okay, fine. We're going to do standard IO. Is there a file? Is it standard file? No, I don't want that. Oh, I forget what it is. It's not form. Oh, it's FS. Centered FS. Read the entire contents of a file into a bytes vector. Okay, so that's probably what I want. Okay. So read, and then you're a path, so that'll be the file name. Sure, let's unwrap you. What's the worst that could happen? Okay, so that gives us a byte vector. Okay. Now I want to convert. Okay, so I want to. I would like to compress it. I wonder if we get the hash from that at compression time, or if I. Yeah, so get hash object. What do you do? Oh, that actually doesn't tell me much about it. Like, what's going on? Yeah, it gets the hash from the bytes of the original file. It's kind of like, that's sort of what it feels like. It's kind of like SHA-1. Okay, so let's go to crates. We want to go to, what was it called? Plate 2. Now we have, okay, so we want to use zlib. So you can do a write zlib encoder. Right, it is zlib, right? It's not gzip. And that, okay, so that gives me the compressed bytes. Okay, compression default. And then we can just write this all to a file. I think that's what that is. Is that just writing it twice? Interesting. Or am I writing, oh, I'm writing into it, aren't I? I'm adding into it. Okay, this is a little bit confusing. Let's actually go into the documentation. Structs. We want to compress. The zlib. Encoder. I guess we'll just play around with it and sort of see what they want. You should look on CodeCrafters for what's wanted. Yeah, so if we take a look at this, CodeCrafters wants us to write it as a blob into there. So we're gonna have to create the directory for it, and we're gonna have to get the hash of it too. What I was wondering is, will it give me the hash? Like, will Flate give me the hash of it as well? But I don't actually think it will. But I wanted to try that out. Okay, yeah. So this is what they want. They basically just they're gonna do a cat file on it to try to get the contents of it back. So let's see. I think we need to SHA it. Can I SHA with the Flate? There's no hash, there's nothing like that. I don't think so. Yeah, we should SHA-1 it before. I was just wondering whether or not this would give me the SHA. I don't, like, I'm not seeing that it will. What else do we have? What else have they given us? Oh, they gave us SHA-1 for hashing. Okay. So that's in our dependencies. We can use this. Okay, so we have this SHA-1. So if I load up the, okay, so we could probably get that. Let's create a function here. So we'll do a function like get SHA. So if I get the file name, which is a stir, and we're gonna return, let's say, a string of the SHA. I want to. It's not necessarily like, okay, so reading that is probably gonna be fine. We have our file name, we don't own it yet. Let's also that SHA equals get SHA file name. Okay. Now what can I do? We want to do SHA-1 SHA-1 That's not helpful. Okay, so it's not like immediately obvious just looking at it what I need to do, so we'll just go to crates and take a look at it there. Oh, okay, so you're not, yeah, okay. We'll go take a look at that. Okay, usage. Okay, so we use SHA-1 new, so create a new SHA object. Process the input message. Okay, so this hasher, we update it and we hand you in. And then we finalize, and that gives us... Oh, a hex of this. Okay. So we're gonna, okay, so we create a new hasher object. I'm gonna move this over to the side so I can use it, look at it at the same time. All right, so we're gonna do let mute hasher equals SHA-1 new. And then we're gonna update it with the contents of this file. So we actually have, the files. That's going to be, now it's bytes. So I think that having this be a string slice of U8 is what we want here. So we're going to say hasher update file. And then I want to return, okay, so then we're gonna get that the hash equals the hasher dot finalize. We need to update you. Let's give you that, okay. Trait bounds are not satisfied. That's not. Okay, so okay, you brought in because you thought that you were the correct thing. Okay, no function or associated item named new for struct core wrapper. So I need to import. No, okay, so it wants me to import, use hex literal. Use hex. Okay, so it wants me to use SHA-1, and digest 2. Oh, that's what it was. I need the digest. Okay. That gets it. Okay, so now we have our hash. We finalize it. Now what type are you? Unknown. Cool. Now finalize. Oh, unknown for that as well. We have no errors. Okay, that's good. Now, okay, so we update it, we hand it the file. Now it has this assert equal, and then we have this result, which I think is in hex. How do we convert the hex to a string? Can I do, I don't think I've ever done it before. I also probably just want to, let's debug the hash. Okay, now this will crash when I try to run it, but that's going to be fine. So I've already, I already have this file test out here. So I want to do a cargo run hash object w test. No such file or directory. Oh, wait. That's because the test is out here. That's fine. Okay, so here's the hash. Okay, so I need to now convert this into the appropriate thing, which I forget how to do. Now it says that this is acquired hash digest in the form of a generic array, which in this case is equivalent to a U820. So this one is like 28. They use hex to convert this over into it. So I want to convert hex to string, hex to something. Oh, is that the reason why we had hex? From hex. Okay, so use the traits from hex. Oh, okay, so then I do from hex, and then I can do... That gives me a buffer? The example is the other way than what you want. The one here, yeah. I want 2 hex? Oh, do I want 2 hex? This is turning it into a hex, right? Okay, so if I finalize, we have this hash. Now, if I take the hash and there's not from hex, there's not a 2 hex. Ooh, Okay, so I need to pull in hex. You have bytes, you want a string of hexadecimal digits. Okay, that makes sense. So we have these bytes. We have an array. We have essentially a vector of U8, and I want to turn them into a string with hexadecimal digits. Okay, that I could then turn into a string. Now hex here, which I want to say we also have access to. Yeah, we have access to hex. So hex, instead of from hex, we want to hex. So we take this thing and we just encode hex. Okay, so we need to use hex to hex. So if we use that, was it 2 hex? No, it's encode hex. Type annotations needed. Okay, so encode hex, as a string. Okay, and then we will just return this. Okay, so then we get our SHA-1. Let's now debug out the SHA. And let's see what we got here. There we go. Okay. So that's good. So we've now got our SHA sum. Excellent. So that's step 1 of this, right? We get our SHA. We want to we have our file. Okay, so we have our file. We also need to compress this into, okay, so we need to compress. So we'll also take the file of that. And do I want to, is this going to be a string? I don't know what this is going to be. Let's see, we're going to use the, what is it called? Plate. Oh, it's the zlib. The zlib encoder write. New, and what do you take? Which will write uncompressed data to the stream. Oh, compress. Okay, so it's going to be the exact same thing that we use with this hasher, isn't it? So we're going to do let mute, like, encoded. Oh, expected 1 argument. Maybe not. I guess the other thing, though, is that I need to create the file. I need to create the folder for it as well. Okay, so what are the things we need to do? We need to, we get the SHA-1. Okay, so we get the SHA, we get the file. We need to also function create like the folders. Create the folder. So we need the SHA sum, so that could be a stir. And then, okay, so the file name is that. Okay, get the file, get the SHA sum. We're going to create the folder. Probably like have to put it in there. We need to compress. So we need to compress and hand it in the file. And then print the 40 SHA to standard out. So then print the SHA, right? So So print SHA. I mean, that one's going to be pretty simple, but okay. Create a folder. This is also going to be the SHA. They're handing it. Okay, so that's going to be like the general idea. I may want to use the read version. I wonder. Yeah, I'd probably use the write version, right? But okay, so let's do this one thing at a time. So before we do compress, we're gonna do this one at a time. So we want to create the folder. I want to print out the SHA. Let's print out the SHA regardless, so we can at least see where things go and test those out. So this is gonna be, we're just gonna print. And we're gonna print the SHA itself. So that's, I mean, this is pretty simple. We want to do SHA. We also want to do standard IO. What was it? Standard IO. Standard out flush. Okay. Okay, so that will print that out. Okay, so if we don't do anything else right now, let's get rid of all of our warnings, except those two are going to be fine. So if I cargo run hash object with this test, ooh, this one already exists because it's exactly something we already have in there before. So let's do let's update test. So cat. So another line. Okay, so I want to see that it creates that 8.3. So we want to do an LT of .get objects, and we want to see basically .8.3. So maybe not LT. We're going to do LL .get objects 8.3, and then we should see a file in there, or at least we should see that directory being existing. Oh yeah, and that's the other thing, is that I should probably use the print line, and so I think that's all I need here. Then I want LL of get objects 8.3, and you don't exist, and that's fine. Oh, in this folder, so like the first two letters might already exist, and so I need to check to see, like, create it if it doesn't exist. Okay, so that's gonna be in standard create hex. Okay, so I need our I think it's an FS. Okay, a builder used to create directories in various manners. I don't know if that's exactly what I want. So creates a new set of options of default mode. Okay, so you can use recur. It is considered an error if the directory already exists unless recursive mode is enabled. Interesting. So I could just do recursive mode. Interesting. Okay. So let's do this dir builder. Put this over in a side so I can reference it. So in we're gonna do a let's. I don't actually know if I need multiple things. So we're just gonna do dir builder new. Let's add in recursive mode. So true. Oh, create it anyways and check if the error exists. It avoids tactile failures. Okay, that's good to know. So yeah, instead, there's another. Okay, so instead of recursive, then we then do create. It wants a path, so we have to figure out what the path is going to be. So that our path is going to be equal to. So we know that you're going to be. Now this is going to be interesting, right? Because we so far are in the same directory as the .git, but it's very possible that we're not. Like, so normally I think that git write object would not care where you are. It's going to find the .git home directory first and then go from there. This one, I don't know if they actually care about that. So like, I think here we could say like, normally we should find the .git folder in case we are nested in. That's YOLO because why not? Happy smiley face. Okay, so we're just gonna say, hey, we have .git objects, so we're gonna start there. So I want we probably have to format this. So format we're also gonna have to get the first two characters of this too. So we have the stir, so get objects. And then I want the SHA 0 2, something like that. Can I two string that? That, okay. Now create the path. Now I could unwrap it, or I can check what the type is. Let's try just unwrapping it right now and let's see what it yells out to me. All right, so we have an unwrap on here, which is not great, especially for this specific case, but let's not worry about that. Let's YOLO this. So we are going to run this with our test. Okay, no errors, no problems. Okay, so I want to now check. Okay, so it's the 83. Hey, it exists. It exists. Okay, so if I run this again, we should get an error. Yeah, it kind of already exists. So we should probably handle this. So we need to handle the case that the folder already exists. If that is so, we don't want to crash. So we could basically convert this and check it. Compress. It looks like we were about to write this. So maybe we should just run this and see how it is. So if I do a cargo build, I guess I don't need to do a cargo build because I could do a cargo run, can't I? So do cargo run. What was it called again? It was hash object. -w, and then I want that to be this test file. Oh yeah, we get this error. That's fun. You should handle the directory already existing. Yeah, we should. I think that's what it was. Kind already exist. File exists. Ooh, okay. Oh, because it's a new file. It's a new file. Yeah, so we should handle the directory already existing. So in create folder, we're just blindly attempting to create. So do builder, create path. Okay, so basically in .get objects. Oh, and then this. This is the new folder. Okay, okay. We need to handle the case the folder already exists. If that is, we don't want it to crash. Okay. I'm surprised that its file exists, not folder exists. But okay, let's so we see that it's an already exists error message. Let's see what type of error this is. So we're going to match on this. So if we get an okay, what do we get from this? I don't think we care about this, right? So if it's okay, we just... You're that? Oh, Zilby, you're done? Okay. We don't do anything. But if you're an error... What type of error are you? Cool, you're an error. That's very helpful. Oh, we need to add the recursive option. I thought the recursive option was only for just one folder. It's an IO error. I'm kind of surprised that it doesn't tell me that it's like trying to be an IO error, because like you would think that this would tell me. Okay, so it's an IO result, which then we would assume would be an IO error. So if you were an IO, it'd probably be standard IO error. Already exists. Then I want to basically do the same thing as okay, right? We just ignore this. If it's an error with anything else, let's print the error out. And then I guess we'll crash. Oh, we can panic. We can panic and then write you can say like error creating the directory. Well, okay. So it would have been nice if you told me what this is. Oh, it's a struct, it's not an enum. Ugh. Oh no. Is there some kind of like you can get error kind? Okay. So we can get the error data. That's not fun. Okay, so we got debug for error gives me that. The recursive option eats the already exists error for you. Yeah, we chatted about that, and the community seemed to think, at least last week, that we should do the other way. okay, so if I turn on with the builder, which kind of makes sense if we do this, because otherwise we have to like get this error and then figure out what the error is. So if I just say, okay, let's go back to what we had before. We just unwrap this because reasons. But if I do dir builder new, recursive true, this shouldn't cause the problem. So, okay, we do create folder. So we do create folder, then we're going to compress the file, and then we're going to print the SHA, and that's all. So we're not trying to save the file yet. So if I run this again, yes, then here's our SHA printed out. So perfect. Okay, so that gives us that creates the folder for it. We get this hash, and so what do I want to do? Okay, so we create the folder, we compress it, we print the SHA. We've already got the SHA, which is why we're able to create the folder. So then we compressed it. Okay. We compressed it. Oh, we haven't actually compressed it. We haven't done this at all. Okay, so that's what we need to do next. We need to compress it. So that is zlib. We need to use zlib for that. No, not zlib. What plate 2? Yeah, this is what we're working with. Okay, so compress. I moved the documentation over to the side so I can read that a little bit easier. Okay, so we're going to start with, we need a new encoder. It wants us to pack, okay, so we have new vector and then compression default. So we're going to do let our encoded, I think. So like, it calls it like an, oh, it's the encoder. So encoder, you have to be mutable. Equals, okay, so zlib encoder, and so we're going to use this plate to write zlib encoder new. We're going to pass it an empty vector, and then we have to tell it what type of compression to use. So in this case, we want just the default compression. Okay, so then what I can do is I can tell this to write. So all I need is a bytes, which I think we already have here represented by this file. So we can just do encoder. We want to write all the file, and that's it. And then, okay, so compressed bytes. Then we finish it. What are you upset about? Unused result. Oh, this doesn't show that it uses the result. Oh, interesting. Okay, so let's just, and then compressed bytes. No. Finish, and that's okay. So got it. We're gonna do encoder and finish. You return a result, so that's and you're gonna return back the something. The W, the type. Okay. What is that? Let's my favorite way of checking to see what something is just do that and let the compiler yell at me. Okay, so it's a vec8, so it's bytes. So we're gonna get a vec of u8. There you go. Okay, so okay, so create folder, print SHA, we compress it, which means we need a let our compressed file. It's equal to that now. We're printing the SHA out, and then I need to save the file. That's what the next thing is. Now, I had like one question is like, can I do more TDD with this? And for like actually saving to the file directory and doing that, that's a little bit, I don't know like how much TDD I want to do with that. With like choosing the file and folder names, that's definitely TDDable. Like I can have something that gives me a path, which if we notice, okay, so that's like a path to the file. The file name. Okay, so I need to get, okay, so what does this mean? To save, okay, so let's create the save. We'll do save, save file. We're gonna take in the file, which will be that. And I don't know if we're gonna return anything. I think that's just gonna do it. Okay, so if I wanted to, what are the things that I need to do here? We need to figure out the file. Okay, so basically we just need to get the path and we need to write to it. We already know what the folder is. I think this create folder should return the folder path. Should probably return this path. So if I do something like that, can I pass in a reference? Then we'll return path. Okay, so we're gonna have the file itself that we're saving, and then also I want the folder path. Okay, save file. We're gonna have not the SHA, it's gonna be the compressed file. And the folder path. Okay. So if I get those, we're going to, I want to create the path from this because like, because this has a side effect of actually saving it to the disk. I don't know how like TDD I can do that. You also need the rest of the SHA. Oh yeah, I do, don't I? I need the SHA. Okay. Yeah, so let's have file SHA. It's good call, Cringe Teeth. That is that just a stir also? Yeah, it's just a string here, so okay. Now that's the full SHA. So oh, this is something that we can use TDD on, because to get the file name SHA, okay, so we need the file name SHA, and the folder path is already helpful. We just need the missing the first two bits, characters. So let's do this. I want to create this as a mod, and this is going to be a config test. We're going to do a mod. Okay, so I want a function that I could call from within save file. No, I want a function that can call from the top one that gives me the file SHA. So should provide file SHA. So let's create like a SHA, and we'll just make this up, do something like that. The expected file SHA is going to be everything but the first two. So all of that. And so I want a function here to create. Okay, so get file SHA. Get SHA from yeah, get file SHA. Ooh, so this could be a string, but we can also return a string slice too, because we're not taking ownership of it. And so I could just do that. Okay. Then, okay, so we have expected, and so now we can do get a result. Hand it the SHA. And then I want to insert equal that the result is the same as the expected file SHA. You are unhappy. What's expected identifier? Oh, do I have to have like mod tests? I have to have a name for it, don't I? Yeah. Okay, so if I run this, okay, so if I do a cargo test, this will run and it will say, okay, left is not equal right because we have this 2QY3. Okay, so we start with we just returning the full thing. Okay, it makes sense. So we have the red. Now we want to do the green. So to do this is pretty simple, right? I want to get the SHA, and I want to get from 2 to the end. And give me a reference to it. And passing test. But this also shows a little bit of documentation for like, hey, this is what it's supposed to be, minus the first two characters. Okay, so we can now be confident that that's working. So get file SHA, we're going to do that in our hash object. So right here, get file SHA, hand it the SHA. And now we know that our save file is going to get the correct file SHA. Okay, so we need to do a standard, I think it's the file system, right? We need to, is there a write file? Write a slice as the entire contents of a file. Ooh, should I do this one? I mean, this looks like it's gonna work. Otherwise, we have to do a file create and then a write all to it. Oh, you got to rank 3? Oh, congratulations on that. You can create a function that splits the full SHA to a tuple of 2 strings. The first two, yeah, I guess I could have done that. I'm keeping it as like the full SHA, and then I'm just sort of passing slices around for it. I can see both, like both I can see both together. If I were to do that, I might want to create a struct that wraps around it so I can have functions to sort of like stitch them together. So I don't have to remember like, okay, a tuple of 2 things or something like that. Make it more readable. Oh, because then I could have like get file SHA and all that stuff on the struct. That would make a lot of sense. Okay, write a slice as the entire contents of a file. So we're gonna get the path. So we need a new path. So that's gonna be we're gonna format. We're gonna have our format folder path followed immediately by the file SHA. And then you are the file itself, the contents. Let's see, we're right at content, which is going to be the file. And my guess is that you have a result. So let's just go ahead and unwrap you and cause you to error out, whatever, that'll be fine. So we're saving, so we got no errors in here. So if I write this, okay, I wasn't actually paying attention. Where was we had the, here it is. Okay, so it should start with A3 and then we should get like BD36. So A3 BD36. So if I were to like LT get objects, so did I say A3? I said A3, right? That folder should already exist, shouldn't it? Oh shoot, there's folders over here too. No. Which I already forgot. I'm now looking at so many numbers, like my brain immediately conflated them all together, and now it's like, what's the one I'm looking for again? Okay, well that's not helpful. Let's just run it. What can possibly go wrong? Cargo run. Okay, so it's A3, so now I can do LT, just do LL 8.3. Okay, yeah, that makes, yeah. So get objects 8.3, show me that. Okay. Okay, I think this is gonna work. And I want to say that this is the full challenge. So if we take a look at this, okay, implement the get hash object command. We store it in file minus the first 2. Okay, so then it will use the get cat file. So I should be able to now do the cargo run cat file and then name it. Is it the full blob? I think it's the full blob, right? I think it's that. That didn't do. Oh, with the dash P. I forgot the dash P. There we go. Okay, so that extracts it out, and we get it exactly. We get it what we want to. Perfect. Okay. Thank you for that, everybody. Also, Mickey K. Hello. All right, so let's. We have some warnings here. Don't we? No, we don't. There's no warnings whatsoever. I think we're good to go. So let's add everything. Gonna get commits. This is, we are writing the creating the blob file. So creating a blob object. All right, and let's let me full screen this. We'll we will push. So it has to run this the first time we go through it. I think that they have like a runner that's sleeping, so they have to wake it up and create it. And so that's, I think, what this is. Because like in future times when we run this, it doesn't take nearly as long. Oh no! Okay, so expected standard out to contain 06562 got 33. Oh, that's like not even close. So we did, okay, so we printed this out. So the only thing that I could imagine, okay, oh wait. Oh, they're doing all the tests for everything. Nice. Okay. Do.txt. Do we get a C? Oh, we don't get a C. Do.txt. That would be nice for us to see exactly what that was. Here's my guess. We used the wrong SHA sum. That's the only thing I can think of. So we use this digest SHA-1. I wonder if that's not right. What else do we have in here? I mean, okay. I don't think that's what I want. Oh, the other thing I guess we can check. Do I have SHA installed? I don't have a SHA-1 installed. Are you sure you should digest the file before compression? Maybe not. I always thought you're supposed to digest. I always thought you're supposed to do that before compression. Maybe you're supposed to do it afterwards. So let's try that. So if okay, so we get the file name, we get the file. Now I've been getting the SHA from that. If I compress the file here, and then we hand it the compressed file. Let's see if that still works. I don't have SHA-1 sum on my computer installed. I think I need to reinstall it. Or for some reason, oh wait, I have SHA sum. That's what it is. Okay. Okay, SHA sum is the same as SHA-1 sum. Okay, good. So the only problem is I don't have that file. I could cheat because I now know that they're going to use a file named this. Okay, let's try this one test at a time, right? Like we only do with one change, one test. So we are what is it called? We're going to compress the file before getting the SHA sum. Okay, so expected to contain BDF got 45. Okay, so at least this is the same, right? From the last time? No, it's not the same. Oh, it's a different file every time? Uh-oh. That is going to make it harder. Maybe not. Use the SHA some command on a real get. Oh yeah, we could do that too. Oh, you know what? You know what I could do? This would be the easiest way to do this. Okay, so let's do this again. We're gonna do a cargo run. All right, so we know that the SHA sum that I did with my file was 8.3, right? So if I do a get cat file, how do is dash W? No, it's not cat file. It's write file. Hold on. Get write file. Oh, it's hash object. That's why. Oh yeah, that is very different. Okay, so okay, we know it turns this into FFD7, which is like not either of the things that I do. If I do a SHA sum of test, that gets me 8.3. Okay, so that's the same thing. If I do a SHA sum of get objects FD that gets me 7D, which is also not this. Okay. All right, we need to go take a look at they have a link to plumbing commands. And then here, does it say that it's a SHA? Into 40 char SHA to standard out. It just says SHA. Okay, can I, what is it? Write file? Oh, you don't have write file. SHA? No. Remember you had to strip out some data of the clear blob file. Maybe it's related. Maybe. That could be. Oh, right, it was hash. I keep on forgetting it's hash object, not write file. Okay, this is the SHA-1. Okay, so it's verified. It is a SHA-1 hash. So therefore, the thing you're suggesting, Cringe Teeth, might exactly be it. The output from the above command is a 40-character checksum hash. This is the SHA-1 hash, a checksum of the content you're storing plus a header. Wait. Plus a header. Is that the header we stripped? Or is that something else? Wait. Where's this header? Git first constructs a header which starts. Oh, no, we have to do the opposite. So we had to strip it out. We have to create it and add it in. Oh, that's what it is. Okay. So we construct a header which starts by identifying the type of object, in this case, a blob. To that first part of the header, Git adds a space followed by the size in bytes of the content and adding a final null byte. So blob content byte size. Okay, so the choices are like blob, tree, and other things, right? So like for this specific one, for hash file, I think, hash object, it's going to be a... No, that's probably not true. We don't know for certain it's going to be a blob, do we? I can probably get away with hard coding a blob. So my guess is it's blob or tree are the two different object types. Okay, so I have to find out whether or not we're being handed a object. Okay, so here's what we can do. Since we're talking about blob object, let's continue on with what I call the hostile developer pattern, and I'm just going to hard code blob in, because why wouldn't I? Let's full screen you. Right? So we want to let's create something to calculate the name of it, because this will obviously change later. So we know this is going to change and it's going to break when we do the tree. But until then, we're going to do git header blob tree commit and tag. Oh, okay, that makes sense. So blob tree commit and tag, and we're not going to be using tag, so we're probably only going to get commits. So we're going to have to take something in, so something in here, and then we're going to return a header, which is going to be a string. So I guess right now is that we'll just make this an empty string like that. So should create blob header. Now, how we're going to use this? Okay, so should create a blob header. So what was this again? It explained it in here. So a header is going to be an identifier. So here we can, if I hand it if I hand it the file, so let's do like let content, it's going to equal to a string of like hello world. Okay. And actually, I don't need this to be a string, do I? Because I would probably just hand it a stir. So this might be good enough. Actually, you know what? Let's do this. It's like exactly what they have here. All right, so we're going to identify the type of object, in this case a blob. So our result, so that expected result is going to be equal to, it is lowercase blob, so blob space, add the space followed by the size in bytes of the content, followed by a final null bit, which is this thing right here, so 16. So we expect there to be a 16, followed by this null bit, which that's fun. Like that. Okay. So then let's get the result. Get header, we'll hand it the content. Now, in the future, I'll probably have to hand it something else so it knows that this is a file or not. So we'll deal with that in a little bit. Expected 0 arguments. Okay, so you need the content. Okay. What are you upset about? Missing bracket to begin the Unicode escape. Oh, I didn't. Oh, that's how it works. Okay, so like that for Unicode escape. Okay, so you're suggesting that I do a \0? So like that? Is that a 0 or an O? Oh, I didn't know that. That's the same as a null term. That's cool. So if we have that, we have a result. Okay, so that means let's run our tests. You should fail. You should fail. You both passed. Oh, I would help if I wrote an actual assert. So assert that a result is equal to our expected result. Now we should fail. Okay, so we get our left and right. So that should probably, you know, do something. Okay, so to get header, so we're eventually going to need to like figure out what type this is. And maybe it's going to be as simple as like something else passing in like a Boolean or like an enum. For right now, that's future me's problem. So we're going to just assume that everything is a blob, but we can kind of write this in like a way that this is, that we can like maybe figure out what this, we can deal with this later. So we're going to do like our object type is going to be just a blob. And then we need the size. So can I get content size? Length probably is the length in bytes. Okay, no, that's perfect. Okay, the length in bytes. And then we're going to return a string. So we're just going to do a format. So this is going to be our object. Object type. What was it? Object type space our size, and then something like that. We are going to get the shop probably. Okay, so we're going to get the file. We need to get the header. So get header. We handed the contents. That's going to be the file, I believe. Okay. Ooh, interesting. File. Okay, we get the file name. We get these as bytes. Ooh, okay. This might, okay, so we need to change. I didn't do this right. We have a U8 here. So hold on. So I need to hand it not this content, but the, what is it? B. How do I convert the string to bytes? Is there like a as bytes? There we go. Yeah. You're upset. So content is now going to be a U8. Where's our problem? Oh, right. Okay. Well, I'll have to fix that in a little bit. Because we're going to have to create a new thing together with the header. All right. So now if I run this, okay, still passed. So that passed with us passing in the bytes. So that's good. So now we can get the header. So we hand it the file, which is the bytes. That gets us the header. I need a new content to the file. So I need to add this in. So this is that file with header. We're going to how should I do this? You take in bytes. Can I like prepend? I can prepend this, right? We can say file insert at position 0. I want to insert the header as bytes. Okay, what? Oh, headers bytes. Can I? No, dereference. I need dereference here. Oh, just expected U8, not. Right, I don't want to insert. Yeah, extend. I keep on forgetting. We've been making really good use of extend. Extent. Okay, so extend. You're not going to take in that first thing. Okay, so file extend. You need to be mutable, which means, we don't need this. Okay, so we're going to file extend. Cannot be known as. Okay, so hold on. There we go. Okay, so we extend it. Okay, we add it to the header. Now I want to get the SHA, and we're going to hand it the file. And then we're going to compress. So we get the file, then we compress it, then we do that. The header needs to be evacuate. It is. I did this as bytes on it. Oh, you're right. This is gonna put it at the end, isn't it? Oh, that's funny. That's hilarious. I did this wrong. Okay, so let's do this as okay, so we're gonna do let now I could just shadow the file. I might want to do that, right? So like we're gonna do let file is equal to the header. You know what? I don't want to do that. I want to do this as content. So we want content equals our header 2 bytes into bytes. As bytes. That let's do into bytes. It's okay. We're gonna consume that there. Okay, so then I want to content, we're gonna extend the file. Okay, so extend the content with the file. That's fine, that's fine. Then we're going to hand you the content for the SHA. We're gonna hand you the content to compress. Figure out the folder path is from the SHA, print the SHA out, and then save the file based upon the compressed file, the folder path, and the SHA. Okay. No errors, no warnings. So if I do a cargo run, that's not good. Permission denied. At line 54. Oh, so I tried to write here. What did we try to write to? Okay, so we're basically saying, okay, we're going to write to get objects fd. Oh, wait. Is it permission denied because this already exists? Oh, I think this permission denied because if we do a get, it was hash object. FDFF. FDFF. That's exactly what it is. Okay. Now, this lets me just overwrite it, doesn't it? So we should be able to handle that. When we save the file, do I get a permission denied? Permission denied. That's not really helpful. Yeah, I want to do some. Well, no, if it. Yeah, wait. If it exists, do nothing because the SHA sum would indicates that nothing has changed about it. So that's a good idea. If it exists, we do nothing. We just continue to save that. So basically, save file. We do something like this. So save the file to disk if it already exists. Don't do anything because it's all based upon the SHA. Auto deduping is one of the benefits of get object storage. I guess, yeah, that kind of makes sense. Do you ever, I guess it probably does remove them at some point in time. Our thing never removes the objects, doesn't it? Like they just stay there forever. Oh, probably commit would remove it. A commit would remove it. FSCK can check for dangling objects and clean should remove them. Okay, we're not implementing those commands, so we're not doing the right things. We're not doing everything. Okay, so we get our path. Now I could check to see if this exists. What do we have here? So write. I probably want to try to do file create and then get the error out and then find out, okay, if it already exists, don't do anything. That's probably what I want to do. Okay, so we have this path. That's okay. We have our full path we're going to. Code Warrior, hello. So we're gonna have our file. We should not name it that. This is gonna be like the file handler. So what is that? File? Not that type of file. File. Create. Do you have like an exists? Okay, so open create opens a file in write-only mode. This function will create a file if it does not exist and will truncate if it does. That's not what I want. Oh, I could do open options. Returns a new open options object. This function returns new open objects that you can use to open or create a file with specific options if open or create. Okay, so if I do options, set the option to create a new file or open if it already exists. Is this what I want to do? Oh, is there path exists? That might be better. Okay. Returns true if the path points at existing entity. I like that. Okay, so if I exist and then we path in, yeah, okay, one argument. So we hand it the path. Just a Boolean. So we do, if this exists, then I want to just do an early return. So we'll use this as a guard clause. So if you exist, return. Otherwise, go ahead and write this out. Do you need ownership of the path? Oh, you need a path. Okay. So I need to let path. You take in stir. Can I just pass the path into you? No. Expected a reference. Okay, so we can do that. Okay, so if path exists, I don't need to hand you anything, except we just do that and that. No, that. Okay, so if the path exists, we're done. Otherwise, write the file to the path. Okay. Yeah, I saw create new and open options. But if this works out here, this feels pretty... I guess it's like two hits to the file system, but you don't do this that often. So, I mean, I think it should be fine. Okay, so if I do cargo run hash object w test, there it goes. Okay, so it no longer has a problem. Let's remove that file. Let's try this. Okay, so this is, we are hashing object and saving it. This time with a header. Hey, and the test pass. Oh, I'm so sorry, Sylvie. I did not mean to shock you. Here, have some head scritches. Okay, so that works. We're able to, okay, so it hashes the object and then it pulls that back out and make sure that whatever we put in there, we get out successfully. So that's really cool. Is there anything we want to do to clean up this? The only thing I can think of is for this path here, I do get this and save file. I do this thing here. I don't think I really need to, although you need to take in a reference to a path. I could do this. We're gonna say, oh, can I do a from? No. Oh, I was really hoping I would be able to like just throw this straight in here and do that, but no, it doesn't look like it. Okay, we'll just stay with the shadowing then. So we create a path string and then we'll just shadow the path and turn it into this thing here. Then we check to see if it exists. Oh, you think there might be a two path on string? Let's find out. I don't see a two path on here. I did not need a... Yeah. I'm not getting any errors? Oh, wait, okay, now we're getting errors. Yeah, no method named two path on this. Maybe it's only on stir. Okay, so we could try doing an as stir. No path. It's better if you do path new. Oh, interesting. Okay. Yeah, I've not really used path very much. So let's try that. Let's just set a path and we'll do this here. We'll do this properly. So new path. Okay, so we're gonna do new and then right, because we're gonna start with get. Ooh, the folder path coming in here. Hold on. Okay, there's some spaghetti we need to sort of unravel here before we get to there. So in save file, so when we do the save file, we hand it this folder path. Create folder. Gives us a string back, and the string being the path, right? So this should really be a path object. So we should really return this as a path object, which means that you should now be a path equals path new. Here we do our .get. We join objects. And then we're join whatever this is right here. I guess like the first two characters, the SHA. Not there, there. Okay. Oh, that gives us a path buff. Is that all we want? Is a path buff? Path buff is more like a path builder. Okay, so I can probably as a path turn it into a path. Into path? Yeah, path buff can generally be used as path in terms of passing. Okay, so let's just create this and let's just use path buff then. So an owned mutable path. This type provides methods like push and set extended to mutate the path in place. It also implements deref and path to path. Okay, I probably want path buff because I want to be able to add to it later. Okay, so we do that. Everything's good here. So now we get our path. Here, from, okay, when we create the folder, we get folder path, and now I handed in a reference to the folder path. So really, do I want, does that implement clone or copy? I mean, I couldn't just give ownership of it. I think that'll be fine. Go to save file, and folder path is now going to be a path buff. Now I could make this mutable, and I can update it, or I can just clone it. If I mutate this, oh, I own it now, so it's mine. Nobody else can do anything with it. It's mine. We're gonna do a folder path. So really, we could just name this path. And we're going to push in the file SHA. What? No, I wanted you to just go there. And then I don't need you anymore. I don't need you anymore. There we go. Much better. This use path, I think this feels like a lot better because now I can just say like, hey, add this to the path, check to see if it exists. If it does, we exit out, we guard, so we're guarding with this, and then we go. We do the thing. So now I've taken ownership of this, so I'd probably want to clone this in if we need the path later on, which so far we don't. So we should be good to go. No errors, no warnings. Let's make sure that this still works. So git commit refactored to use a path. All right, and this should still run and all that fun stuff. I know, sorry about that. I failed with my own one. Expected Humpty NS Scoopy vanilla as standard out. Got unknown command ls tree. Oh, ls tree. Yeah. Okay, so all of the other tests are passing. So it's still working. We're now on read a tree object.